to record. 4, 6, 9, 10, 12. Okay, got it. 4, 6, 9, 10, 12. So let's go to 4. Remember, an equation is an expression, two expressions that are set to equal each other. So the first thing we should do is write the two expressions. And I'll write it over here. So on this side, so we're doing number 4. Let's call this container A and this container B, right? Put the equal sign. So let's get the expression for container A. Container A has 200 liters of water. It's being filled at a rate of 6 liters per minute. So we have 200 liters already in the container. And we're adding, right? Because it's being filled, so it's increasing at 6 liters per, there's my per minute. Okay? And then container B has 500 liters of water. And it's being drained, so it's losing, how much is it losing? Losing 6 liters per minute. Okay, and there's my equation. So now I just get to solve. There is no distributive property. I can't combine like terms on both sides because there are no like terms on the left and the right. There are variables on both, so I'm going to get rid of the small one, and the smaller coefficient is negative 6m, so I'm going to do plus 6m, plus 6m. 200 plus 12m equals 500. These two go away. Now I'm going to subtract 200 from both sides. That goes away. I get 12m equals 300. Divide this by 12, divide this by 12. And 300 divided by 12 is 25. So m equals 25. So in 25 minutes, the two containers are going to have the same amount. And then I'm just going to do a check. So it's 200 plus 6 times 25. And on the other side, it's 500 minus 6 times 25. So let's see if we get these correct. So here is 200. 6 times 25 is 150. Here's 500. And 6 minus 25 is 150 as well. 200 plus 150 is 350, and then 500 minus 150 is 350. So look, in exactly 25 minutes, they will both have 250 liters in their containers. Número 6. A 12-inch candle and an 18-inch candle are lit at 6 p.m. The 12-inch candle burns at 5 inches every hour, and the 18-inch candle burns 2 inches every hour. At what time will the two candles be at the same height? Well, okay, so let's call this the 12-inch candle. And this is the 18-inch candle. So they burn at different rates. So the 12-inch candle. So it starts at 12 inches. So imagine a candle is 12 inches tall. And it's burning, so this height's decreasing at 0.5 inches per hour. The 18-inch candle, well, it starts at 18 inches. And then every hour, it's 2 inches. It loses 2 inches every hour. Okay, so those are the two expressions, one for the 12-inch candle, the other one for the 18. We're going to get rid of the 2h here. There's no distributive property, sorry. Can I combine like terms? No. But there are variables on both sides, and negative 2 is the smaller coefficient. So I'm going to do plus 2h here, plus 2h here. Here I get 18, because these two go away. And here I get 12, and then negative 0.5 plus 2 is plus 1.5h. We then do minus 12 on this side, minus 12 on this side. 12s go away, I forgot the h. 1.5h equals 6. Divide both sides by 1.5. And h equals 4. So in 4 hours, both candles will be at the same height. And let me do a check. So the check is 12 times 0.5 times 4, right? On the other side is 18 minus 2 times 4. So 0.5 times 4 is 2. And then 12 minus 2 is 10. So in 4 hours, the 12-inch candle will be a 10-inch candle. And in 4 hours, the 18-inch candle, well, 18 minus and 2 times 4 is 8, and then 18 minus 8 is 10. So in 4 hours, the 18-inch candle will also have a height of 10 inches. Okay. What is it next? 10. Okay. Here we have a store. Trophy costs $12.50. Engraving. So when you're writing, you know, whatever, championship, the words, the year, every letter costs 40 cents. The other store, the trophy, the same trophy costs $14.75, but every letter costs 25 cents. All right, so a little slight difference there. So what we need to do is set up. So let's go. Let's call store A and store B. In store A, you need to pay $12.50 plus 0.40 cents per letter, and I'm going to use the letter L. I think that's letter E, actually. Yeah. Now in the other store, you pay $14.75 plus how much per letter? 0.25 cents per letter. So if you had to choose, I mean, at what point will these two start? With how many letters will these two stores charge you the exact same value? So if you had this amount of letters, it wouldn't matter which store you would go to. Well, distributed property? No. Can I combine like terms? No, not on the left side, not on the right side. I have variables on both sides. Let's get rid of this guy because it has, what do you call it? It has a lesser coefficient, so we got to minus 0.25, minus 0.25. This goes away. We're left with 14.75. And on this side, 12.50 comes down, and 40 cents minus a quarter is positive 15 cents, 15 L. We're going to subtract 12.50 from both sides. That goes away. Let me put it over here at the bottom. 0.15 L equals $2.25. Divide both sides by 0.15, 0.15, and we get, I think, 15 letters. And L, the number of letters, is 15. So if you knew the amount of letters you want to engrave and it was 15 letters, it wouldn't matter which store you would go to because they would both charge you the same price. But I'll do a check. $12.50 plus 0.440 times 15 letters. The other store is $14.75 plus 0.25 per letter, so 0.25 times 15 letters. So let's see if we get the same price. So here it's $12.50. 0.40 times 15 is 6. So on this store you end up paying $18.50. On the other store it's $14.75. And you're going to engrave 15 letters, so let's multiply 0.25 times 15, and you're going to be paying $3.75 for the engraving of the letters. So if you add 14.75 plus 3.75, you should get 18.50, and you do. So at this point, with 15 letters, it doesn't matter which store you would go to. More than 15 letters, that's a different story. So one's going to be more expensive than the other. But at 15, it doesn't. And then we're doing 12. Okay. We have Lenny and Carl. So I'm going to write Lenny over here. And Carl. Okay, so they both make money. They both start in different salaries and different annual raises. But in how many years will they be making the same amount? So Lenny starts his job making $55,000, plus they give him $2,500 raise every year, per year. So let's write per year. And then Carl starts at $62,000, and they give him a raise of $2,000 per year. And those are the two expressions. We set them equal to each other. Now we get to solve. There's no Extruded product or combined like terms. The coefficient that is smaller is 2,000, right? This is 2,500. So let's get rid of the 2,000. Get rid of that. Minus 2,000 away. That goes away. 62,000 comes down. 55,000 also comes down. And then 2,500 minus 2,000 is just 500. Why? We're going to subtract 55,000. Subtract 55,000 on both sides. That goes away. 500 comes down. 500y comes down. And then here we get 7,000. We're going to divide both sides by 500. Right? And that goes away. Y becomes isolated by itself. 7,000 divided by 500 is 14. So the answer is, in 14 years, Lenny and Carl will be making the same amount of money. And let's check. So 55,000 plus 20,000, 2,500 times 14. That's what Lenny, right? We're going to multiply by 14 to see how much Lenny's going to make in 14 years. And then we're going to do the same thing for Carl. Carl is 62,000 plus 2,000 yearly raises for 14 years. And supposedly, at the end of 14 years, they'll be making the same amount of money. So 2,500 times 14. So this is 55,000. This is going to equal 35,000. And this is going to give us a total of 90,000. So in Lenny, in 14 years, will be making 90,000. Carl, let's see, 62,000 plus, what is that? 2,000 times 14, which is 28,000. And if you add 62,000 plus 28,000, you get 90,000. So there, we know that we're correct. So our answer of 14 years is correct. In 14 years, they will be both making the same amount.